This is the Building Automation Monthly Podcast with Phil Zito, episode 167. Hey folks, Phil Zito here, and welcome to episode 167 of the Building Automation Monthly Podcast. In this episode, we are going to be continuing our series on controlling HVAC 101. In last week's episode 166, we talked about space control. We went through how VAV systems work within spaces, and we talked about the primary variables that you control within the space. In this week's episode, we are going to be focusing on air handling equipment. So we're going to take a look at some key airside concepts. We're going to move from there and look at some of the most common equipment types to include rooftop units, mixed air units, and 100% outdoor air units. We'll talk about some concepts associated with those systems, and I think you'll get a pretty good picture of how HVAC on the air side works from a controls perspective. So this week's episode is sponsored by our Control Sequence Fundamentals course. If you like what you've been hearing in these recent podcast episodes and you're thinking to yourself, man, if I understood HVAC better, I could really take my career to the next level. Or maybe you're a manager and you're realizing that finding folks who can quote unquote do controls, but also have HVAC knowledge is pretty hard. And so you're saying, man, what can I do to help folks get that HVAC knowledge and do it quickly? Well, our Control Sequence Fundamentals course is the answer to that. This fully online, on-demand course will teach you everything you need to know about controlling HVAC equipment in the quickest amount of time possible. You can find out more about that by going to buildingautomationmonthly.com/167, scrolling down to the Control Sequence Fundamentals logo, clicking on that, and you'll be able to look at the course syllabus, read some student testimonials, and enroll in the course. All right, so let's get started. When we are thinking about airside systems, we need to understand what we're trying to accomplish. Now, I talked about that within a space, we want to provide air to that space, right? And that space, once it has air, that air then allows us to control the three primary variables. I'm like, man, I can't speak tonight. Temperature, humidity, and CO2. Now, when we're looking at these systems that control the airflow, we're looking at systems that are often called rooftop units or air handlers. Now, a rooftop unit is typically known as a package unit. It's a self-contained unit, so everything within it is contained within itself. DX coils, gas heat. It is essentially a single piece of equipment that is not really dependent on any other pieces of equipment. Now, air handlers, while this isn't always the case, air handlers tend to be systems that are utilized to go and serve multiple zones. Granted, rooftop units can serve multiple zones, but they tend to serve multiple zones, and they also tend to use hydronic systems for the conditioning of their air. Now, granted, there are air handlers that use DX and gas heat, but most air handlers, you'll find that they will use hydronic, especially in areas that have significant degree days, meaning that you either have really hot days or really cold days, and you have temperature conditions that are in the higher ranges of those days. That's an area where using hydronic systems tends to function well. So there's four main variables whenever we're working with airside systems that we need to be aware of. This is true for rooftop units. This is true for mixed air units. This is true for 100% outdoor air units. And here are kind of the four variables that I look at. And if you understand these, and there's a very specific reason why these are in the order they're in, but if you understand these, then what you're going to find is that your programming's going to become easier, your sequence checkouts are going to become easier, your functional test is going to become easier, because these variables, they build upon one another. And so it begins with our safeties, right? So we always have to think that safeties come first. Our pressure sensors, our low temp alarms, our smoke alarms, all of these safeties come first. And these are both going to be hardwired interlocks like we talked about. I think it was episode 164. But these are also going to be software where we are going to look at the conditions of these safeties, what state are they in, and then make a decision. This will become more clear when we talk through some sequences related to our airside systems. From there, we move on to that dampers must be controlled. So we look at the dampers that are associated with these systems, right? And we look at them and we control them, and we look at kind of what the whole system is doing. And that drives how we control the dampers. So for example, if we are looking at a mixed air unit, how we control dampers is going to be completely different than a 100% outdoor air unit or a rooftop unit. So damper control is going to be different based on the type of unit we're working with. So we've got our safeties, we've got our dampers, and now we can look at our fans and they start moving air. And our fans, what do they exist for? They exist to pull air out of the building. In the case of exhaust fans, they exist to pull air through the return duct into the unit in the case of a return fan, or they are designed to pull or push air down the supply duct in the case of a supply fan. So fans move air, and only when we have our safeties and our dampers under control and our fans are moving air, can we start to look at conditioning the air with our coils. Now, this is something that if you've been doing this for a while, you're like, yeah, Phil, this is freaking obvious. But there's so many folks who are new to our field. And there's so many folks who have been in our field for a long time, but they don't think systematically. And because of that, they approach programming, or they approach troubleshooting, or they approach commissioning or functional test, and it's very haphazard. It's never consistent. And they wonder why some jobs go great and some jobs go bad. It tends to be, when I see that going on, it tends to be because they don't systematically think about how these airside systems should start, right? So looking at this again, let's take a basic rooftop, right? Or let's take something a little more complex than that. Let's take a mixed air air handler. So the mixed air meaning that you have return and you have outdoor air, and the two mix in a mixing compartment or in a mixing section. And then that mixed air goes and it hits some coils, and then it hits a fan, and then it goes down the supply duct or the discharge duct, depending on what you want to call it. So our safeties in that case, let's say that this mixed air unit is a constant volume, we could still have pressure safeties. So we could have those. We could have a damper interlock. We could have a low temp alarm. We could have smoke alarms. All these safeties would have to be true. And then our mixed air dampers, we want to make sure they're controlled. We don't want our outdoor air and our return air damper both being closed at the same time. The air's going to have nowhere to go. The fans are going to start pulling the ductwork in. It's just going to be all kinds of bad. Then our fans need to move the air. We need to make sure these are turned on, because we can have cold water going through a coil all day long, but if there's no airflow, then nothing's going to happen. And only when we've met these conditions can we then go and actually condition our air. So it's at this point that we start conditioning the air, and we control to a variety of variables. We could have a constant discharge air temperature set point. We could have a discharge air temperature set point that's reset based on average zone temp. There's a variety of ways we could do this, right? Okay, so at this point, I want to dive a little bit deeper into each one of these four things: the safeties, damper control, the fan control, and the temperature control. And then we're going to look at a couple common systems, and we'll talk through those sequences. Realizing that this is an audio podcast, so some of this visualization, it's a little hard to visualize because you're listening to me talk. So I'll use examples as best I can. If you are finding this something difficult to visualize and you are feeling like you need this information, I'd really encourage you to check out our Control Sequence Fundamentals course. So safeties, the primary safeties I tend to look at are pressure safeties, contact safeties, temperature safeties, and life safeties. That's kind of redundant, but so pressure safeties, you have low static and high static. Okay, so especially with variable air volume systems that have VFDs, so you vary the airspeed or you vary the frequency. So vary the speed or the frequency. VFD is frequency, VSD is speed, but they roughly have the same effect. You vary essentially the volume of air that is being pressure or pushed through the ductwork. So you've got pressure safeties. Those are going to measure high and low static. So that'll make sure your fan doesn't blow out or suck in ductwork. You have contact safeties. These can be anything from damper position contacts. These can be contact safeties, like those are the main ones I can actually think of. Dampers. That's the main ones that I use contact safeties for back when I was in the field. So I'd make sure I had a damper status. And this was especially true on like 100% outdoor air units where there is no return duct. So normally the return and the outdoor air damper are opposing one another. They're installed as such, so as long as they don't slip on the damper shaft, they're going to oppose each other. So if you have 100% outdoor air, you will have 0% return. And if you have 100% return, you'll have 0% outdoor air. As long as that linkage or the programming is proper and the actuators aren't slipping on the shaft, you should not have issues with your damper states. And then we have temperature safeties. These are primarily low temp alarms. Although sometimes you will have high temp alarms, especially with steam systems. I guess another contact safety would be condensate overflow as well. So if you get a plug in your condensate line, that would be a potential safety. So you don't want to start flooding things. You could also have a float switch if you had DX and you're having a lot of condensate runoff there. That could stop the unit as well. So I guess there's a couple more contact safeties. And then finally, life safeties. Those are primarily fire alarm and smoke detectors. All of these typically are going to be wired as a normally closed safety for your control circuit that's running through them. And they will only break that circuit from that normally closed state when they're actually an alarm. So then dampers, as I mentioned, there's primarily two types of dampers. There's proportionally offset dampers that I just went through, right? That's your outdoor air and your return air dampers. Now those, as I mentioned, as long as they're not slipping and the linkage is messed up, they should be fine. You rarely should damage your system with proportionally offset dampers. Open and closed dampers are the primary area you need to focus on and be careful with. I'm not saying proportionally offset dampers don't fail. I'm just saying that of all the times I've seen units damaged, it's most of the time it's improperly doing 100% outdoor air units or rooftop units, and someone's closed the dampers because maybe they reverse the state. I see this quite a bit on lawn potentially, where they get the states wrong. And I see this sometimes on backnet systems, just depending on the manufacturer and how they reflect damper state. But that's why it's so important to do point-to-point checkout. Fans move airs. Now, you've got primarily two types of fans. Variable speed fans, which those are typically you're varying the speed or frequency of the fan and you're driving towards a static pressure set point. So static pressure is typically 2/3 down the longest run. Although I don't really like that rule of thumb, that 2/3 down the longest run. I actually like it to be in a run that gives a good sample of a variety of boxes. So if you have an intermix of cooling only and heating only boxes, or cooling only and heating boxes, then I like to have the 2/3 sensor, quote unquote, the discharge air pressure sensor. I like to have it on a duct run where I get a good intermixing of those box types, so that, because sometimes you'll have reheat boxes that'll be open more than cooling only boxes, and you don't want to be starving a branch of ductwork. So then constant volume, these are just running constant volume. Now they come in kind of two flavors. One that you'll see commonly with fan coils will be 3-speed fans, low, medium, high. Others are just constant volume, and they're balanced by the balancer. And they're set to provide a specific amount of airflow. And these are either direct to a space or to constant air volume boxes. Whereas variable speed, those tend to be for multi-zone variable air volume boxes. So that's where you'll tend to see variable speed fans. And then finally, as I mentioned, coils condition air. And there are 3 primary coils that you'll deal with. You'll deal with preheat coils, which is meant to condition air right after it hits that mixed air section. So especially if you've got a CO2 requirement and you have to bring in a certain amount of fresh air for ASHRAE 62, and you're trying to bring in that fresh air, but it's really cold out, you've got to preheat that air, so you'll tend to find preheat coils. Those will fail open typically. So when you're thinking of failure states, preheat coils will fail 100% open. Cooling coils will tend to fail closed. Sometimes they'll fail open. Some folks' philosophy is if we keep the liquid moving, that we should go and have less likelihood of freezing, and our preheat coil should help us in such a way so that we don't freeze. I'm not a professional engineer. I haven't studied whether cooling coils are better to have open or closed. I typically would close them. That's typically what I did. But I'm just saying I've seen some sequences where they have them open as well. I'd love to hear your thoughts in the comments as to why you would close or open cooling coils. I'm just telling you what I did from a control perspective the majority of the time. And then reheat coils would be open as well. So there you have it, right? We've focused in on kind of the 4 variables that you're going to control regardless of your system type. And there's several different system types you're going to run into. As I mentioned, rooftop units, 100% outdoor air, mixed air units, makeup air units, fan coil units. You're going to run into a variety of different system types. The majority, though, if I'm sitting there in your shoes and I'm a new control salesperson, or I'm a new controls programmer or technician, and I'm thinking, what do I need to know the most? I would say focus on these 3 things: a rooftop unit, 100% outdoor air unit, and a mixed air unit. If you can get controlling both from a programming and a technical perspective, as well as just a general knowledge perspective, these 3 things, if you can get controlling them down, you will be in a position where you can handle energy recovery units. You'll be able to handle mixed air units, makeup air units rather, fan coil units, etc. Because at the end of the day, it's going to be all the same principles. All right, so let's take a look at single zone rooftop units, right? So it's at this point, single zone rooftop units, I assume you understand, because we just covered it: fans, dampers, coils, valves, sensors, safeties. We talked through all of that. We've talked through sensors in many podcast episodes before. So what we need to think when we're thinking about a rooftop unit, the first thing you need to understand, okay, and this is not really HVAC control, but it's just something that's important. Is it going to be manufacturer controls and you're using a BACnet interface, or are you controlling them? Because your ability to sequence systems is going to be dependent on whether you're putting a field controller on, or if you're pulling in BACnet or LAN or whatever points from that rooftop unit. So that's the first thing you got to figure out. Once you know that, let's say you are putting controls on this unit. It's no different. It is kind of different. I'm like, it's no different, but it is kind of different. So the primary thing you're going to be doing when you are working with a rooftop unit, okay, is you are typically going to be controlling to a zone or a set of zones. And typically you're not going to have variable flow. The main reason why you tend to not have variable flow is because these units are typically not serving boxes where it would make sense for you to have variable flow. And they're also typically using DX, which there is hot gas bypass and things like that. But with DX, you want to have a constant flow across the coil. That's direct expansion. It's basically the same concept as your chiller and cooling tower, that evaporator coil and condenser coil. So you want to make sure that you have a consistent flow. That's why it's really important. That's why I hammered it, right? Safeties, damper, fan, coils. If you have flow, you will almost never ice a DX coil. I mean, yeah, if you're, there's some ways you can do it, which I'm not really going to get into here, but your likelihood is going to go down. Okay, so with rooftop units, we typically have a constant volume flow. We're controlling it, and we really will tend to have maybe some dampers, maybe an outdoor air that is typically set at a static position by the balancer. And we typically have a straight return air duct that doesn't have a damper. So then from there, we have our coils, right? And here we tend to go and have a DX coil and some sort of electric heat or gas reheat. So we will tend to control these systems with either a single PID loop that has a 50% bias, meaning a 50% start. So that 50 to 100% would be your cooling, and that will be scaled from 50 to 100 to 0 to 100. And from 50 to 0 is going to be from 0 to 100 heating. So you can use a single PID loop or you can use dual PID loops. I tend to like to use a single PID loop. That way I can tune that. But if your capacity is really different, so if you have a much larger capacity on the cooling side or on the heating side, because let's say you're in an area that has really high heat or really high cooling demands, then you tend to want to split your PID loops because you're tuning as far as how quickly you can overshoot your controlled variable, your temperature, is going to be affected by the capacity of that coil. So for example, if you are in a space like I live in, Wisconsin, where you have large heating needs, on those shoulder months where it's not quite cold, but it's cool, if you don't have a separate PID loop and you have a single PID loop using that 50% bias, that works well kind of in the middle of the US or in more temperate climates, you will actually end up overshooting and you will see heating loops that don't really control well. That's why you can see in the shoulder months heating or cooling overshooting and spaces being too cold or too hot. So it's really important that you understand that. That is a really important concept that a lot of folks don't pick up in their careers. They look at, they either get trained to use 2 PID loops or they get trained to use 1 PID loop, and they don't really understand why. So that's why. So as I mentioned, you have DX cooling. With DX, I mean, there's your common things, right? You can't stage your compressors on and off. You've got minimum on and off time, just like any piece of electronic equipment or mechanical equipment, like a chiller or a boiler. You have your minimum on and off times. You don't want to be short cycling them. Not only is it inefficient, but just like your car or any other motor, every time you turn it on, that's some wear and tear. And so if you're cycling it on, off, you're going to shorten the life cycle. So that's where you tend to see a 5-minute minimum on and 5-minute minimum off. And you tend to see thresholds at which you'll go and engage your DX compressors or your strip heat, etc. So from there, right, now we move into looking at 100% outdoor air units. So rooftop units, they're typically used for schools or constrained or, buildings with limited spaces. So small office buildings, etc. Now, some rooftop units, as I mentioned, are variable air volume and they serve VAV boxes. But those are the exception to the rule. Those tend to be larger tonnage units. Now, when we talk about 100% outdoor air units, why do we use these? Well, there's three main reasons we do this. One is to avoid the reuse of contaminated air. So we don't want to go and have this mass of contaminated air if we're serving an operating room or if we're serving a clean room. We also want to avoid the need for excessive airflow. So what do I mean by that? Well, with a mixed air unit, if we are controlling we're controlling CO2 control, or we're trying to do improved humidity control by separating latent and sensible space loads. Well, by having a 100% outdoor air unit, we can actually go and hit our outdoor air requirement, and we can separate those latent and sensible space loads at much lower volumes of air. What I mean by that is if I have to hit 200 CFM outdoor air, in order to do 200 CFM outdoor air and hit what I need to hit at the space, I may need to bring in a lot of air on a mixed air unit. Whereas with a 100% outdoor air unit, it's 100% outdoor air, so I only need to open as much as I need. And also, when we are trying to separate those latent and sensible space loads, so we're basically trying to remove moisture and energy out of the air, when we are returning air, we're returning that energy versus a 100% outdoor air unit. Now, I know some of you who are like in Florida or in Louisiana, you're like, Phil, this wouldn't work there. I agree to a point. You're absolutely right. Typically, folks will have units before the 100% outdoor air units that exist solely to remove that humidity. But in most places, 100% outdoor air units, what they can do is they can actually remove a lot of humidity using coils and things like approaching saturation. If you're familiar with psychrometrics, which if you're not, I encourage you to go and study that. But they remove that energy out of the air. They remove that moisture out of the air. And by doing that, it then goes into the building at a lower humidity level, and you're not returning moist air. You're just exhausting moist air. So it's an improved humidity control sequence. I tend to see this utilized in spaces that are sensitive to humidity. So, as I mentioned, we also have mixed air units. Now, mixed air units, they exist to help us avoid conditioning unneeded outdoor air. And they also allow the reuse of preconditioned airflow. So if you're wondering why we use mixed air units, that's why. The main reason is the reuse of preconditioned airflow. You have this air, if you have a tight envelope in your building and it's not really slipping out, and you are stopping infiltration and exfiltration, you've got a perfect balance of your building, then you want to go and reuse this preconditioned air that's already in there. So let's say you're in a temperate climate and you've got the air sitting there at 74, 50, so 74 degrees, 50% relative humidity. You're kind of in that thermal sweet spot for ASHRAE 55. And you want to go then and keep circulating that air, because why go and recondition all this air from outside when you can just circulate the air? So mixed air units are used for that. Now, the thing is, with mixed air units, we introduce some new control strategies. So whereas with outdoor air units and rooftop units, we tend to be controlling either to zone temp or discharge air, mixed air, we introduce mixed air temperature control, especially if we're utilizing economizers. So we'll have a mixed air temperature sensor and we'll drive economizer control. And then we have outdoor air damper minimum position reset. And this is typically fed by either CO2 or mixed air temperature control PID loops. So these loops will drive a reset of the outdoor air damper minimum position. And so this is stuff that is a little interesting to program. Now note, we haven't got into building static. We haven't got into exhaust control. I don't know if we'll get into that in this episode. We may cover it. Next week's episode is going to be on hydronic systems, so I'm pretty sure we're not going to cover it there. But we'll see. We're already at 30 minutes, so I'm not quite sure. I try to keep these at 30 minutes long. There's just so much to cover here. So mixed air temperature control and outdoor air damper minimum position reset, these require new PID loops. And when you're going and you're circulating this air within a building, you have to be cognizant of how much air you're letting out of the building, how much air you're bringing in, and how much you're circulating. And that all affects your building static pressure. So as I mentioned, we do focus in on one of the two things with mixed air units. And we talked about this a little bit when we were talking about the two volume types. We were talking about variable volume and constant volume. So when we are dealing with constant volume, we are going to focus on temperature reset. So variable air volume is where you vary the air volume, and then you have boxes that regulate airflow based on temperature, which then drives a PID loop, right? Well, that you stay at a constant 55 degrees. That's because at that temperature, when you look at a psychrometric chart and you come in at 55 degrees and you then go to the right of the psychrometric chart from that 55 degree temperature, where you're basically most of the time at saturation, and you go to the right, you will see that, let's say you're returning 60 degree air, right? You're returning 60 degree air. You bring that down to 55. So you're following that saturation at dew point kind of down the chart. And you can't see this right now. I'm visualizing it in my head. But you're reducing the amount of grains of moisture per pound of air. Then when you go back across the right on the psychrometric chart and you get to that 72 degrees, you are now at a lower relative humidity. And that's how you lower the humidity. That's why we use 55 degree air with VAV systems. Now, with constant air volume, we don't have that capability to have variable air volume based on the space temperature. So what we do is we'll have a constant volume and we'll look at the average space temp and we'll actually reset the discharge air or the supply air, depending on what you want to call it. But most of the time it's called discharge air. And we'll actually reset the discharge air at set point, typically between 55 to 65 degrees. That's because we are not varying the air volume, which is within the space. All right. So there you have it, folks. A lot of information around HVAC systems. I hope that this has really helped you. I'm sure it's created some questions for you. I encourage you to go ask those in the discussion board at the end of the webpage at buildingautomationmonthly.com/167. And if HVAC is interesting to you, this is a small little taste. To give you some perspective, this has been 30 minutes of airside systems. I think in our course, we spend 7 hours on it. To give you some perspective just on airside systems, not counting VAVs, hydronics, etc. So if you're looking to learn HVAC, I really encourage you to pick up that course. It will be one of the best investments you've made in your career. With that being said, thank you so much for being here. As always, I encourage you to reach out. Let us know your thoughts if you'd like us to answer anything on the podcast. Speaking of the podcast, Big Puff 18 left us a review, and I really appreciate that. Good 5-star review talking about how we're giving him a lot, I'm assuming it's him, a lot of information related to building automation systems. So if you feel like leaving a review for the podcast, I'd really encourage you to do that. Helps more people to find the podcast, and you can do that at iTunes or Stitcher. Until next time, thanks a ton for being here. I appreciate every one of you all being here. Thanks so much. And I look forward to talking to you next week where we dive into chillers and boilers. Thanks a ton. Take care.